Hey guys, welcome to this video on question 2 for the 2019 level 2 algebra exam. So in this video I'm going to be walking through the 2019 level 2 algebra paper. So A, simplify fully, leaving your answers with positive indices. So you have 9a squared times b to the power of -4 to the power of 0.5. So 0.5, that's basically saying 1/2. And when something is to the power of 1/2, it just basically means square root. So 9a squared b to the power of -4 square root of this. Okay, so basically square root of 9 is 3, square root of a squared is a, square root of b minus 4, so that becomes b to the power of -2. However, it says you want to leave your answers with positive indices, and this is negative indices, so you want to change this into a positive indice. Alright, so basically you know b to the power of -2, that can be rewritten as 1 over b squared. So this will become 3a times 1 over b squared, which equals to 3a over b squared. And that should be your final answer for this question, which is an achieve level question. Alright, so 2a over 3b to the power of 4 to the power of -2. So once again, we want to change this -2 into a positive 2. And to do this, we can just flip the fraction, and the -2 will become a positive, it will become squared. So basically, if we rewrite this as 3b to the power of 4 over 2a to the power of 2. So now we just square the numerator and the denominator, so you should get 9b to the power of 8 over 4a squared. And that should be your final answer for an achieved grade. Alright, write 2c plus 1 over c squared minus 9 plus c minus 2 over c squared minus 4c plus 3 as a fraction in the simplest form. Okay, so for this question, we want to make the denominator the same, and make the denominator the same so we can add the two fractions together and then simplify as far as we can. So 2c plus 1 at the top, c squared minus 9, that can be rewritten as c plus 3 times of c minus 3, plus of c minus 2, and c squared minus 4c plus 3 can be rewritten as c minus 3 times of c minus 1. Alright, so now we want to make the same denominator. So we have c plus 3 and c minus 3. We do have a matching c minus 3, so matching c minus 3. However, we have a c minus 1 on the right hand side, and we have a c plus 3 on the left hand side. So we want to have everything the same. So 2c plus 1 over, and this is missing c minus 1, so c minus 1 times, so top needs to be multiplied by c minus 1 as well. So c minus 1 times c plus 3, c minus 3, plus of c minus 2 over c minus 3 times of c minus 1 times of the c plus 3. So what we do to the bottom, we must do to the top. So c minus 2 times of c plus 3. So now we can simplify. So 2c plus 1 times c minus 1, that becomes 2c squared plus c minus 2c minus 1 over c minus 1 times of c plus 3 times of c minus 3. We're going to add that to c squared plus c minus 6 over c minus 3, c minus 1, c plus 3. Alright, so now we can add the two numerators together because the denominator is the same. So we can, now we have 3c squared plus 2c, not plus 2c, we haven't simplified this yet. So this one becomes c, so this becomes 2c squared minus c minus 1 plus c squared plus c minus 6 over a common, sorry, this line is very messy, so over our denominator, which is c minus 1, c plus 3, c minus 3, and that should simplify. We're going to continue up here. Should simplify to 3c squared. 3c squared plus minus c and plus c cancels out. 3c squared minus 7 by the looks of it. Let me double check. Yeah, that looks right. Over our common denominators, which is c minus 1 times c plus 3 times c minus 3. So as you can see, this cannot be simplified anymore because 3c squared minus 7 cannot be factorized. So that should be your final simplified form, and this should be a merit level question. To get an achieved, I'm thinking if you can get perhaps even if you make everything the same denominator, you might even be able to get an achieved here. But I'm not too sure. Once again, I'm just estimating the grade boundaries. I'm not too sure. I'm not too sure because I don't know the mark schedule yet, so I have no idea what each question is and where you can get the grades. I'm just using an approximation from past year papers. Alright, so moving on to the next question. So factorize fully fm minus 6gn plus 3fn minus 2gn. Alright, so the thing I like to do first is just move the m's and m's together and n's and n's together so we don't get mixed up in the future. So if we have fm minus 2gm minus 6gn plus 3fn. Alright, so as you can see for this one, m and m is common factor, so we can take it out. M times of f minus 2g. Now minus n is the common factor here, so minus yeah, 3f is actually the not 3f, 3n is actually the common factor here, so 3n 2g plus I'm doing something wrong here. 2g negative 3n, so that's negative 6gn, yep. Alright, so I think the best thing here to do is plus 3n actually, because we want to make this and this the same in order to factorize. So if we do plus 3n here, then this will become negative 2g. Negative 2g times 3n is negative 6gn, yep. And then we're going to plus that onto 3n, so f. So right now these two are the same, so therefore we can rewrite our equation as so this and this come together, and this stay the same. So m and 3n come together, and f minus 2g stays where it is. So m plus 3n times off f minus 2g. And that should be our final simplified form here. And that should get you a comfortable achieved grade here. Alright, question D, the controversial question. The shape below is divided into rectangles. All measurements are in centimeters. The shaded rectangle has an area of 9 centimeters squared. Find the area of the rectangle ABCD. Alright, so I'm going to work through the question first, and after I finish working out the answer, I'm going to tell you what was really wrong about this question. But I'm going to work it out first, okay? So it's told that this shaded area here is 9, so this is 9 centimeters squared. And we know this side length is y, so therefore this side length also has to be y. So therefore we can set up your equation. So y minus 8 times y equals to 9. So y minus 8 times of y equals to 9. So you can simplify. So y squared minus 8y equals to 9. Y squared minus 8y minus 9 equals to 0. And if you factorize this, you should get y minus 9 times of y plus 1 equals to 0. So therefore, y equals to 9 or y equals to negative 1. But y can't be negative 1 because, let's just say length can't be negative. So we know y equals to 9, and we're trying to find this, we want to find the area of the rectangle. So the area of the rectangle, base times height, so x minus 4 times of x, so basically area equals to x times of x minus 4. So basically area equals to x squared minus 4x. However, we can write an equation for x in terms of y because we have here y minus 8 and y plus 2, and at the bottom we have just x. So basically y minus 8 plus of the y plus 2 is equal to the x. So y minus 8 plus y plus 2 is equal to x. However, we do know that our y value is 9, so we can substitute that in. So 9 minus 8 times of 9 plus 2 equals to x. Sorry, this is plus here. So 1 plus 11 equals to x. Therefore, x equals to 12. And if x equals to 12, we can find our formula for our area. So a equals to 12 squared minus 4 times of 12. And if you plug this into your calculator, you should get your answer as 96, if I'm not mistaken. So 12 squared minus 48. Yep, that gives you 96 centimeters squared as your answer. So if it's this question wasn't too bad, but I'll tell you the problem here. So the problem here is that if you consider y equals to 9, and if you consider x equals to 12, apparently this length will have to be negative 1 in order for this to be true. Because x minus 4, x minus 4 is 8, so this side length is 8. And because this y here is 9, that means this will have to be negative 1 in order to have this equal. However, in geometry, you can't actually have a negative side length, so therefore this is geometrically impossible. And I imagine that in the exam that some people might have got tricked up on this question simply because they were unable to consider this negative 1. They might have thought they did something wrong with their working, and they might have crossed out their answer because they thought they were wrong. So I can definitely see how this might have messed up a lot of the possible students doing this exam. So it's definitely a problem that I think they should address, because this problem really shouldn't be happening in the exam. I know the mistake doesn't really affect your working. In terms of getting the final answer, it's still the same steps in order to get the answer. I'm just saying that some candidates or some students might have been interfered because they might have noticed the mistake that it was negative 1 side length. So they might have thought that their answer was incorrect, and they might have gone back to recheck or even cross out their answer, which could have affected their final mark. So that's all I'm saying. So hopefully NCAA can be a bit more careful in the future so they don't make this type of mistakes in the exam. Alright, so moving on. One root of the equation x squared plus px plus q is n times the other, where n is not 0. Show that qn squared plus 2q minus p squared n plus q equals to 0. Alright, so you have x squared plus px plus q equals to 0. And one root is n times the other. So you can say this is 1, once again, 1x squared. So therefore you can have x times of x in order to get your x squared. However, we know one root is n times the other. So n times the other, that means one root could be n and another root could be n squared. So basically I could rewrite this equation as x minus n and x minus n squared, because the roots of this equation would be x equals to n or x equals to n squared. So one root is n times the other. So this is correct. So basically we're gonna expand this out. So we're gonna say x squared minus nx minus n squared x plus n cubed is equal to 0. Alright, so now you have this qn squared plus 2q minus p squared n plus q equals to 0. Alright, so as you can see, because okay, so right now this might seem a bit confusing, but if you come back to this equation here, so x squared plus px plus q, you can see that this n squared corresponds to the q on in this equation. That's because this n cubed is without an x, so it's just n cubed by itself, and this is q by itself. So therefore we can identify n cubed as equal to q. And in terms of px, we would factorize this first. We have nx squared minus n plus n squared x plus n cubed. So as you can see, our p value here would be equal to this whole negative n plus n squared. So this would be equal to our p value. So we say p equals to negative n minus n squared. So now this might make a bit more sense. So qn squared plus 2q minus p squared n plus q equals 0. So basically, we're going to substitute these n values into our equation and to prove that it's equal to 0. So qn squared, so n cubed times n squared, that's n to the power 5, plus of 2q, 2 times of n cubed minus p squared, so negative n minus n squared squared, plus of the cube, so plus of n cubed. So now it's just a matter of simplifying this whole equation. So n to the power 5 plus 2n to the power 3 minus, so we're going to expand this, so that becomes n squared, sorry, just hold up, so n squared plus n to the power 4. Wait, okay, I think it's best if we write it out so we don't make a mistake. So negative n minus n squared times negative n minus n squared plus n cubed at the end. Alright, so now we can simplify, hopefully. 2n cubed minus negative n times negative n is n squared. Negative n squared times negative n squared is positive n to the power 4. Negative n times negative n squared is n to the power 3. Negative n squared times negative n on the other side is also n to the power 3. And plus of the n cubed. So now we can further simplify. So n to the power 5. Oh, sorry, I forgot about the n at the end here. Sorry, I just realized. I did, didn't I? Yes, I did. So there's actually an n here. And there's an n here, there's an n here. Sorry about that, guys. But making a bit of mistakes today, so sorry. So n to the power 5 plus 2n cubed minus, so we're going to times everything here by n. So this will become so p 2q minus p squared. Oh, the whole thing times by n. Okay. So we're not going to times that by n. We're going to simplify this before we do that. So this becomes minus n squared minus n to the power 4 minus 2n cubed times of the n and plus of n to the power 3. Oh yeah, it's a bit of algebra work here. So n to the power 5 plus 2n cubed and 2n cubed cancel out. So that's gone. And this becomes negative n squared minus n to the power 4 times of the n plus n to the power 3. So now it becomes a lot more simple, if you can see. So plus everything in the bracket times by n. So negative n to the power 3 minus n to the power 5 plus of n to the power 3. And this will become n to the power 5 minus n to the power 3 minus n to the power 5 plus n to the power 3. N to the power 3 cancels out, n to the power 5 cancels out, so this actually equals to 0. So hence we have proved that qn squared plus 2q minus p squared n plus q equals to 0. We've proved that successfully. Sorry. And this would be an excellent simple question for proving up to here. In terms of a merit grade, merit grade might be, okay, so achieved grade might be writing something like this, perhaps. That might be an achieved grade. To get a merit grade, you might, maybe if you're in the process of simplifying, maybe some step up to here might get you a merit grade. Yeah, I'm not too sure. Yeah, I forgot to do the last question actually. So this question, 96 centimeters squared here, that'll get you an excellence grade. In terms of getting a merit grade, you're looking at achieved grade. I know probably achieved grade is probably getting the y value correct, and to get a merit grade, I'm not sure. Maybe finding y equals to 9 and writing in an equation for x. Maybe this plus this will get you a merit. Yeah, I'm not too sure, guys, but yeah, it looks, perhaps there might be something like that. So, alright, thank you for watching this video on the question 2, level 2 algebra 2019 walkthrough. So it is getting a bit late, so question 3 will be out tomorrow. Apologies for that, but yeah, I hope you enjoyed this video, and I'll see you on the next one. Thank you, bye.